Bet you didn't think you were going to see me today, but I am here. Hi guys. So I want to show you graphing inverse functions, and I'm sorry I'm not here today, but I thought this would be better than anything I could find on YouTube. Plus, you still get to see me. So the big deal with finding inverse functions is that you have to switch the x and the y value. And that's pretty much all there is to it. It's very important that when you're doing that, that you understand that everything that involves the x turns into the y, and everything that involves the y turns into the x. So I want to show you an example problem or two to get you started with this concept. So the first function that I thought that we would graph and take a look at together is 2x minus 4. So real quick for me, I want you to create a table of values, and I want you to create a graph for me. So to do that, just pause the video for a second. And I'd like you to please create a table of values, and you can go from -2 to +2 while you're doing that. And then I'd like you to plot those points and graph it for me, please. So if you pause the video right now and do that, that would be wonderful. So now that you've paused the video and you have a chance to actually take a look at what that graph looks like, I'd like to show you here real quick. I got to fill it in. I didn't do that yet while your video paused. So I'm going to create my table of values right here. And then I'll plot those points. So big deal. I get -0, -4 for my x of my y-intercept, and 2, 0 for my x. And I'll just get a nice line that'll look like this. So this is what my actual function looks like. 2x minus 4 with this table of values and this graph right here. So what we're going to do is we're going to kind of go into a Bizarro world. And Bizarro Superman, if you're not familiar with the comic book, Bizarro Superman is like the opposite of Superman. So where Superman is good, Bizarro Superman is actually the bad guy. So we're going to kind of create that idea where we're kind of flipping everything and mixing it all up. So what we're going to do is we're going to take a look at a new table of values. My new table of values is going to have all of my x and my y values switched. So the point -2, -8 actually becomes the point -8, -2. And -1, -6 actually becomes -6, -1. 0, -4 becomes -4, 0. 1, -2 becomes -2, 1. And 2, 0 becomes the point 0, 2. Now we can actually take a look at what the graph of that looks like. So again, if you want to pause the video here really quick and sketch a graph of that, that would be awesome. I'm going to work on it here right now, but go ahead and pause the video. Okay, so you've paused the video, and while you had the video paused, you probably plotted these points, I would suggest. -4, 0, and then 0, 2 is going to give me a line that looks a little bit like this right here. And that's going to be the inverse function of that. I want to know what the equation of this line is, so I'm not quite done yet. So if you remember, we started with the function f of x equals 2x minus 4. And to eliminate confusion, what I'm actually going to do is instead of looking at f of x, I'm going to change that f of x to a y. So we'll make it y equals 2x minus 4. And then if you remember, we flipped into our Bizarro universe, where we switched the x and the y values. So the x becomes the y and the y becomes the x. And then what I'm going to do is I'm going to take this equation, I'm going to solve it for y. So that involves me adding 4 to both sides, and then dividing everything by 2. So I get y equals x plus 4 over 2. And that's not in slope-intercept form, and I really like it in slope-intercept form because that's the easiest way for me to graph lines and for us to look at this equation and know that it's the same as the graph of that. So I'm going to do just a little bit more algebra. And remember that dividing by 2 is the same as multiplying by 1/2. And that 4 divided by 2 is 2. So my graph becomes y equals 1/2 x plus 2. Okay, so that's the first example problem. If you give me just a second, I want to show you another one. Alright guys, so what I did here for this particular graph is I took both of our functions that we had, f of x equals 2x minus 4, and then the inverse function that we had, 1/2 x plus 2. Now hold on, don't notice this little notation that I have going on here. That notation right here looks like this, okay? So that's the notation for the inverse of f of x. That's a -1 that's up there, so it's not really an exponent the way we're used to seeing it to the negative first power. It's just a notation we use for inverse functions. So I don't want you to get confused when you see that. I just wanted a way to distinguish between my regular function and my inverse function so that you would see the difference other than the color red and blue. So what you should notice here is you should notice that there's very much a relationship here between the red line and the blue line. And that relationship I'm going to point out to you because I can't ask you what it is. But if you look at it, if I look at this, I almost have this like imaginary line that I can divide my plane in half. And this is the line y equals x. And if you look at this, the actual reflection that I have to go from my red line to my blue line happens over the line y equals x. And that's very important with inverse functions. That's actually why inverse functions work the way they work, because I'm flipping the x and the y value. It acts like a reflection across this line. That's extremely important for the rest of this section. Now, I'm going to do 2 more problems here for you so that you can take a look. I'm not going to spend quite as much time going over those, but at any point, feel free to pause the video, ask your neighbor a question, and hopefully we'll get this instruction in you, even though I'm not here. So keep up the good work and just stay focused for a couple more minutes. Okay, guys, the next function that we're going to take a look at is f of x equals x minus 3, that quantity squared. And what I've done is I've already gone ahead and I've filled in a table of values. To do that, I used my graphing calculator. Don't forget about Desmos. You do have the ability to use Desmos as you go through this whole thing. If you'll notice, my table of values, not the best table of values, because this 25, this 16, this 9, that's going to be hard for me to fit on my graph for us to see. So I'm going to continue going down here, and I'm going to get a couple other values. So I'll get the 0.3, and I'll get 0, and I'll get 4, 1, and then I'll get 5, 4, and so on. So I like to come up with that table of values a little bit better than what it is. But if you also remember my section on transformations that we did, you'll remember that this is nothing more than x squared shifted to the right 3 units. So 1, 2, 3 units, and I have a quadratic equation that's going to go over like that. Okay, now this point right here is the point 3 comma 0. And if I did this correctly, you'd come all the way up here, and you'd come up with a y-intercept of 0 comma 9. So those 2 points will come up. I'm sorry about my graph there, but I'm not that good right now. So anyways, that's what the graph is going to look like right now. We'll go ahead and we'll figure out what the inverse function is going to look like. And again, if you remember, we're just switching my x and my y values. I'm not going to go with the first 2 points here. I'll start here. So I'll get the point 9, 0. I'll get the point 4, 1. I'll get the point 1, 2, 0, 3, 1, 4, and 4, 5. Now, if you'll notice what happens on this function, if we keep in mind of what we're doing, we're actually taking that, we're going to reflect it across the line y equals x. You actually end up with a graph that's going to look a little something like this. Whoa, I did not graph that right. Let me fix that for a second. Excuse me. I don't like that there. Because what I'm looking at is I'm looking that my point here, 0, 3, becomes my x or my y-intercept. And the point 9, 0 will go all the way over here and will become my x-intercept. Yeah, not that much better, but it gets the job done here today. So you'll see that that's what the graph will look like. Now, this is kind of something else that's interesting that we want to point out to you. Remember how I said at the beginning of this video that it switches every facet of x and y? That means the domain and the range get flipped too. So if you look at this, the domain of this, because I have an x value defined at all the x values, the domain of this function, any quadratic, is all real numbers. And the range here is going to be, I don't have anything down here. So the range is going to be y is greater than or equal to 3. Okay, y is greater than, 0, not 3. Y is greater than or equal to 0. I was looking at that 3, silly me. Y is greater than or equal to 0. And what that means then over here with this function, it means the domain and the range are going to flip. The domain here was all real numbers, so the range in my inverse function is all real numbers. And that should make sense, because that graph is going to keep going up and down forever. The range in my real function is y is greater than or equal to 0, which means the domain changes to x is greater than or equal to 0. And that makes sense because it's all my x values that are to the right of the y-axis. So x is greater than or equal to 0. Let's try to find that function real quick. So here's my function right here. Y equals x minus 3, that quantity squared. And again, I went into my bizarro world. And in my bizarro world, I switched the x and the y. So x equals y minus 3, that quantity squared. And now what I want to do is I want to solve for y. So how am I going to do that? Let's hear. I'll take the square root of both sides. Square root of x equals y minus 3. Square root of both sides. Now here's an important thing. Don't forget to take the plus or minus. It's plus or minus. And we'll get to why that's important here in a second. And then I'll add my 3 to both sides, so my equation actually ends up being plus or minus the square root of x plus 3. That plus or minus right there. If I was here, I'd show you in Desmos what that actually looks like when you don't have the plus or minus there. But I'll give you the short of it right here. The plus or minus, this is the square root of x plus 3, that top part right there. And if you remember from the quiz you just took, the negative square root of x plus 3 is going to be that reflected version of that. So that's that bottom part. So when I have something that's not a function, I can't deal with it. In mathematics, I got to have this plus or minus here. It gives me both halves of that. Otherwise, I just have one half. There's your second problem. I'm going to do one more example with you before I cut you loose here to do your homework. So take a look at this one more time. Okay, before we go to the next problem, I almost forgot. I wanted to show you both of those previous graphs on the same coordinate plane at the same time so that you could see the reflection across the line y equals x. So the blue curve, again, is my function y equals the quantity of x minus 3 squared. And then this right here is the square root of x plus or minus the square root of x plus 3. So you'll see the red curve and the blue curve, and if you can imagine that being reflected across the line y equals x, you'll see the relationship between the two. Okay, now on to the next problem. All right, guys, so here's the last problem. So it's f of x equals the square root of x minus 3 plus 1. Dramatic pause, intentional. What you see is I started to create my table of values here from -2 to 2 like I had done before. But the graphing calculator and your algebra skills, you should understand that you're going to get errors for all of those numbers right there. Because -2 minus 3 is -5, and the square root of -5, well, I just don't get a real number for it, so I can't plot it on a graph. So the first value that I can actually use is the point 3. 3 minus 3 is 0, the square root of 0 is 0, plus 1 gives me the point 1. Same thing with 4. 4 minus 3 is 1, square root of 1 is 1, plus 1 gives me 2, and so on and so forth. So my table of values really starts all the way down here at the numbers 3, 4. And you'll notice I skipped the 7. And I skipped the 7 because 5 and 6, they don't give me really nice numbers up there. So 5 minus 2 is 2, and the square root of 2, some crazy decimal that I just don't care about. So I'll pick smart numbers down here. 3, 4, 7, and 12. I took those points and I plotted my graph. I didn't get into a lot of detail there. The point 3, 1's important, then I know it goes up. So just remember from our last section then the domain and the range, which are going to be extremely important in this problem. You'll see that the domain is x is greater than or equal to 3, and the range y greater than or equal to 1. So that's going to be really important here. Then what I did was I took those values and I switched my x and my y's, as I go into my bizarro function here, my inverse function. And the same thing's going to happen. There's my graph, and if you can envision this reflection across the line y equals x over here, you can see that guy's going to go like that. It's going to flip over on the other side. And again, then, if I look at those points, I'm going to get these points, and I'm going to plot them. And if I look at the domain with this looks like it's going to be x is greater than or equal to 1, and that makes sense because that's going to be the range of the previous function. And then the range for my inverse function is going to be y greater than or equal to 3. And again, that was the domain over here. It becomes the range over here. Let's figure out what the function actually is, though. So again, I start here, y equals the square root of x minus 3 plus 1. And then I switch my x and my y. So I get x equals the square root of y minus 3 plus 1. And I'm going to go through the process of solving. So I'll subtract 1 from both sides. I'm going to square to get rid of the square root. I'm not going to boil that out. That's too much work. I don't want to do that today. X minus 1 squared. 3. I mean, after all, I'm making the video for you. That's work enough. So I get this equation right here. Y equals the quantity of x minus 1 squared plus 3. Now, I'd encourage you to go to Desmos right now. And if you go to Desmos right now, you can hit pause first, and you type that equation in, you're going to end up with a function that's going to look like this. Go ahead, check it out. Verify I'm right. Okay, so you looked at that and you saw that, yeah, hey, that's right, I do get half of it. What's up with that? When I type that equation in, I get this whole parabola going on there. So what's going on? Well, if you remember, we said the domain of this function has to be greater than or equal to 1. So the graphing calculator doesn't know that, doesn't know how to use all real numbers for the domain of the function. So it tries every single point, and with this equation, I'm going to get every single point. So what we have to do is we have to be smarter than the technology and realize that we only want the x values that are greater than or equal to 1. So that means that that part of the curve doesn't exist in my particular graph, and it can't because of what I was talking about with inverses. So again, if we look at that reflection, if I draw that line right here like this, and I reflect it across that line, I'm going to end up with a curve that's going to look a little something like that. That's the mirror across that line, y equals x. All right, guys, so you got the lesson on inverse functions. I hope you enjoyed my video as my first attempt, so I'm looking forward to getting some feedback from you guys. I'll see you on, let's see here, today is Tuesday, so I'll see you on Thursday for the full class period. Come prepared with your questions. I am after school tomorrow, but not today. That's Wednesday. Tomorrow, Wednesday. So good luck with your homework. You'll find that homework assignment at the bottom of this page, along with a couple other videos that I was going to give you until I got this great idea of putting myself on a video for you. So good luck with your homework. If you have any questions, I'll be here on Wednesday after school or Thursday. Thanks a lot, guys. See ya.